Hello everybody and welcome back to episode 36 of the video series in which we program an entire video game from scratch, from beginning to end, in the C programming language. Before we start, I'm going to take a look at a couple of comments. I didn't really get any questions since last time, just a couple of comments. One commenter says, this kind of parsing is what finite state machines are perfect for. He is referring to, this was a comment made on episode 34, so he's commenting on the work that we just did, the work that we're actually still currently working on, where we parse that CSV file to load the tile map into memory. And he says that kind of parsing is what finite state machines are perfect for. I think this comment was made tongue-in-cheek. I think it was sarcasm. Otherwise, and I responded in kind, actually. I responded with sarcasm as well, and I said I think all programs are actually finite state machines. It's just that sometimes the programmer doesn't always define or know about or anticipate some of the states that the program might be in. All right, onwards. The next commenter says, this channel has less than 1,000 subs because people don't want to learn software engineering. Okay, so by the way, I forgot to mention, we just passed 500 subscribers, and I wanted to give you a sincere thank you for that. I really appreciate it. And I'm not really worried about it. I think that we, I don't know how many subscribers that we're going to end up with, but I realize that this kind of stuff isn't for everybody. Everybody wants to make a game. Everybody wants to make a video game, but not everybody wants to put in the necessary work to really make a video game. The vast majority of people they want to make a video game, and they have all these cool ideas, but they don't want to have to do all of the nitty-gritty stuff that it takes to actually implement those ideas, to put those ideas, to bring them into reality. That being said, there's a very specific reason why I'm doing this the way that I'm doing it. By writing everything in old school C, as opposed to doing something like using Unity, is the first gaming engine to come to mind. It's very easy to slap games together in Unity, and you can see that based on the quality of a lot of Unity-based games that come out. And by that I mean they are of poor quality because the people who put them together, the barrier to entry is very low when you use something like Unity. So I don't mean to bash Unity. Unity is okay, I guess. It's just not my cup of tea. But the reason I'm doing this, the reason I'm doing what I'm doing is because, well, number one, I'm creating the sort of educational content that I wish I would have had when I was about 16 and first trying to learn this stuff. Secondly, I am specifically doing this because I feel kind of like this is a little bit of a lost art, in that for some reason, and I don't really understand why, people keep trying to stop using C, and I don't know why. They keep trying to improve upon it, and in my opinion, they're not really succeeding. But for example, whenever I go to look up programming examples on how to do a certain thing, I almost always find that you'll find examples in C++ or C#, but never C. So I that's another reason why I'm doing this, is because I want more content out there in the world that that's pertains to pure C. Another perfect example would be, we talked about this just last time, where we were dealing with X Audio 2, wherever it is, X Audio 2, our sound library, and it's fixed now. But when I first started using X Audio 2, it didn't even have, like, it wasn't even compatible with C without modification. You had to go in there and hack up the header file to even make it compatible with C. It was C++ only. And I think that is a prime example of how C is so often an afterthought these days, and that bugs me. So that's another reason why I'm doing this. Anyway, enough of that. Okay, so next commenter says, one of my laptops also has variable frequency CPU. It's a small laptop, but okay. The Windows timestamp project looks interesting. Okay, yes. I think pretty much all consumer grade CPUs have variable frequencies in this day and age. This is the year 2020. I think all AMD and Intel CPUs have this sort of like, whether you call it variable frequency or frequency scaling or step down, whatever, and they do it to optimize for energy consumption, power consumption, heat. So, your CPU doesn't have to run at 3.8 gigahertz all the time. Most of the time, 900 megahertz will do just fine, and it'll only ramp up whenever you actually need that extra horsepower. The problem is that makes two things much more difficult for us. Number one, it makes benchmarking much more difficult for us because it's hard to know what frequency my CPU is at any given instant. So it makes profiling more difficult, right? Profiling, benchmarking, how many CPU cycles did a function take, and then I go and look at and then I go and make a change, and I see that the number of CPU cycles taken is different now. But what was my CPU frequency? The other thing is timing. It makes timing difficult. There was a big problem with all CPUs. Let me start over. All CPUs have a timestamp counter, and there is an intrinsic called RDTSC, and it means read timestamp counter. And back in the day, when processors used to be a lot more simple, we used to just have one single CPU core on a processor, and that was it. It was single-threaded CPU. Everything was nice and scalar back then, and then multi-core CPUs came along, where we have dual cores and quad-core CPUs, and then you have an issue where each core has its own timestamp counter, and they don't always agree, and that can wreak havoc whenever your program depends on that timestamp counter, because your thread might call read timestamp counter during one thread quantum, and then it goes to sleep, and then the operating system's scheduler may schedule the thread to wake up and resume on another core, and that other core, if I call read timestamp counter again, may give me a wildly different reading. So that was a big issue. And then, of course, obviously it didn't take long before CPU manufacturers realized that this was a major problem, so they created, invariant timestamp counters, to where you'll get the same reading regardless of which core you read on, this kind of thing. But then, we made it even more complicated by introducing the variable frequency part. And you've got issues where, does your timestamp counter tick at the same rate regardless of the frequency of your CPU core? Or does your timestamp counter tick faster when your CPU is running faster? So getting a sense of time uh, became a lot more complicated due to those two things. Anyway, instead of using, that's why if you go and look at the documentation, Microsoft will say don't use RDTSC. Instead, you should use Query Performance Counter. And the same thing with that Windows timestamp project. Um, thing is like uh, the Windows API function, Query Performance Counter, it may actually end up using the RDTSC intrinsic under the covers. But the thing is, the Query Performance Counter API function has a lot of built-in logic inside of it to determine, what sort of processor do you have? Is it safe to call RDTSC in this way, or should I use some other method to get an accurate timestamp reading, and things of this nature. So that's why Query Performance Counter is much better if you're on Windows, obviously. So that's enough of that. Let's see if we can get some work done. So where were we last time? Let's just fire this thing up. So we've been working on this tile map for a couple episodes, and I'm hoping that this is the last time, the last episode that we have to mess with it. We were messing with this tile map, and it's obviously not, we left off in a broken state. This is not what we want it to look like. So my intent here is to take all of the ones and twos and threes and fours and whatever in this file right here, this TMX file. This is a tile map, and I've explained this, so I'm going to try not to rehash it again. I'm going to take this tile map, load it, see these number 2s right here. This is my tile number 2. These are water tiles. Tile number 1, those are grass tiles. Tile number 1, the grass tile, is a passable tile that I should be allowed to walk on, whereas tile number 2, the water tile, I should not be allowed to walk on. And I may actually even have to upgrade that logic later on if we decide to implement, like, say, a raft or a boat or a canoe or something that you can get into and travel across the water. But that's way down the road. So anyway, when I start the game, actually, I should have closed that. When I start the game, the screen is supposed to mirror this. It's supposed to have 2s where all the water tiles are, right? So I have like this triangle in the upper left-hand corner of 2s that's supposed to mimic the water tiles, and everything else is just grass tiles. As you can see, though, that is not what we get at all. Starting in the very upper left-hand corner, I have a 2. That part is correct, and then one character over to the right, I have a 0, which I can't even explain where I shouldn't have any zeros at all in this array. And then the 1s, I have 1s on top of the water. There shouldn't be 1s on top of the water. And then down here, I have like sort of this thing of 2s in the grass. The 2s should be on top of the water. This is just all messed up. We did something very wrong. And then to top all of that off, if I walk with my character, what I see on the screen doesn't even match what actually happens. Like right here, my character is stuck. I can't move down or to the left. I can move to the right. I can move down here, but now from here I cannot move to the left. Or I cannot move down. So the numbers that you see on the screen aren't even lining up with what the behavior of my character's movement. This is a disaster. So definitely have to fix this. Let's go to overworld.c. Yeah. So this is overworld.c, and it's a game state where we draw our background onto the buffer, and then we wrote this at the very end of the last episode. I didn't even think that we were going to need to write it. It's simply this is what draws all the numbers. See, I'm trying to, like, for each row and then for each column, I'm reading the tile map value, and I'm trying to convert that into a string, and then blit that on top of each corresponding tile. So the first thing that comes to mind is, well, maybe, I mean, I know this isn't my only problem, but maybe one of my problems is that I've got my columns and rows messed up. So I could just reverse. Let's see what this looks like if I do row and column instead of column and row. Let's run that and see what it looks like. Okay, now it's still not right. However, there are two good things about this. I think that this is actually a step in the right direction. The first thing that's good about this is that now, even though it still isn't correct, like I shouldn't have these zeros at all, even though it still isn't correct, at least it matches what the movement of my character actually is. So what I mean by that is that I should not be able to walk on the zeros, because 0 is not one of my passable tiles. Only the number 1, the grass tile, is a passable tile, and that's the only thing I should be able to walk on. Okay? So even though I don't know where the zeros came from, it is good that I can't step on them, because I should not be able to step on a 0. Same thing with the 2s. I cannot step on a 2, even though the 2s should be in the water. So I think this is a step in the right direction, even though it's still messed up. Now, secondly, something else. Immediately, I noticed something else just from looking at this. This first line, where in the water, it says 2, 2, 2, 2, 2, 2. That's exactly correct. It matches the water tiles. And then it turns into 1 when I hit the grass, goes all the way off to the rest of the overworld, which is like 10 tiles long, right? Then move down to the second row. Notice I start with 2 zeros. And then I have 2, 2, 2, 2, 2, which is basically, it's offset by 2. See these zeros? Where did these zeros come from? If I eliminate these zeros, then that will pull my 5 2s back to the left, and that will line up perfectly. And I have a feeling, see how the zeros go, they're in the same pattern. They're off by 2 on each row. What that tells me is that we are loading our tile map incorrectly, and essentially we are something in our tile map loading logic is causing us to skip 2 elements of this 2-dimensional array on each row. For every row, we're somehow skipping 2 elements in the array. And those 2 elements that we are skipping, because we are skipping them, they're left at 0, even though we don't have any zeros in our tile map. But we know that this was a global array that was initialized, 0 initialized. Okay, so it just means that they weren't written to. Those elements, wherever you see 0, is we didn't write anything to them. It's like buffer space or padding space that we don't want. So with that being said, I'm pretty sure that this is golden right here. But what we need to do is go back to load tile map from file. We need to go back to the load tile map from file function and figure out where we went wrong. Somewhere in here, somewhere in our logic, and we know this part works fine. because it locates the width and the height, and it populates that correctly. See, all these memory allocations are okay. And then we line up to the first comma. So, yeah, remember we find the first comma in the file, and then we back up a maximum of 3 characters. Until we find a new line character or line feed character. We back up until we find that, and once we find a new line character, we set the cursor down one more, and that should be the very beginning of our tilemap data. Like it's at the first number 2 right here, which this logic up to this point I'm happy with, because we know that on that first row we have loaded the correct number of 2s. Remember, there was 6 of them. 2, 2, 2, 2, 2, 2, and that lined up with the actual number of water tiles. So that part was fine. But what is not fine is this. Okay, something in here. Oh, I think I have it. Okay, I think I have it. So my problem here is when I get to the end of a line, the end of a row. So let me open this file once more. Let me scroll all the way to the right. There. Let me make sure I'm view, show symbol, show all characters. There we go. Now, when I get to the end of a row, there is a carriage return, and there are 2 bytes at the end of each row, right? A carriage return and a line feed. Those are 2 different bytes, and they're important because, well, I don't really need them to tell me that we've reached the end of the row, because I also happen to already know the width of the tile map. So I could be using that piece of information to know when I should move to the next row, but I could also use the carriage return and line feed to mark the end of a row as well. I could use both. I could do it either way. But here's the problem. When I get here, I should advance. But this is it. When I get to a carriage return or line feed character, my phone is like trying to react to what I'm saying right now, and I don't know why. But anyway, when I get to a carriage return or line feed character, I do want to advance the cursor. However, when I do this continue keyword, I go back up here. The problem is that it increments column. I shouldn't increment column whenever that happens. And what happens is that if I do a continue right here, and I resume execution at the beginning of this for loop, column is increased, but I didn't assign anything to that previous column, and that's why it's a 0. Okay? So what am I going to do about this? How about this? instead of calling continue, how about that? That way, if I do a go to skip right here, it'll take me right up here, and I'll get to run through this. I'll basically get to run through this if loop again without incrementing column, without incrementing the column variable. I think this is it. Let's run it and see what happens. Ladies and gentlemen, we have done it. We have done it. And it works perfectly. See, if I get to the water, I can no longer walk on water. How awesome is that? That is too cool. I still feel like I may have issues when I bump up against the edge of the screen. I still might have crashing issues. Like, I have a feeling if my character were up here in the upper left, I need to basically not. Here, I'll show you what I'm talking about instead of telling you. Process player input, right? PPI underscore overworld. Yeah, now see, we did all this stuff last time too, where I introduced this can move to desired tile variable, and what we're doing is we're checking the tilemap to see, am I allowed to walk on the next tile over or not? But you have to be really careful with this, because you could easily check beyond the bounds of the array if you do it like this. So I think I'm going to have to, I don't know. I mean, I could proactively do something about it, or I could just wait until we start crashing because of it and then fix it then. But this is exciting to me, because this part is done. We're done with the tilemap, I think. And the great news is that we can load tilemaps of any size. If we generate a new map that has a different size, we can load it using the same function. It dynamically creates that same two-dimensional array. Bam! I think it's gonna work great. What I want to do now, I want to move on to something else. And I think what that is I want to now introduce panning of the camera, right? So if well, it's hard to see with all that junk in there. What I could do is turn this off for right now, since we don't need it. We don't need that stuff right now, because we no longer need to debug it. I'm excited. I'm excited about that, because that tilemap stuff was going to be difficult. But I made it look easy, ladies and gentlemen. No, I'm just kidding. I want to introduce panning now. So, and I, again, don't mean to beat a dead horse. I know we've already talked about this, but I'm going to talk about it a little bit again, just for my own sake, I guess. Here we have the entire overworld. That's like, I guess, 10 screens. It's 10 screens by 10 screens, right? So right now we've only been dealing with that right there. And I guess here's our little guy right here, right? But what if we want to move outside of this one area? We don't have any code or any logic that would allow us to move outside of this one screen. Um, Needless to say, I would like, I'm going to need full range of this whole thing, full freedom of movement across this entire world map. So what if I want to walk over here, right? I need to be able to walk over there. There's two ways that we could do this, as far as I'm concerned. Number one, the number one way we could do it this is Legend of Zelda for the NES. Turn the volume down. Let's look at some of the... There we go. This is Legend of Zelda for the NES. Now, I want you to pay attention specifically to the parts where Link reaches the edge of the screen. See, there's no panning or anything right up until he touches the edge of the screen. And then there's like a... almost, I guess you could call it like a scripted swipe where the screen moves into view. But other than that, the screen is perfectly static as long as Link stays and doesn't touch the edges of the screen. When he touches the edge, basically the entire game freezes and the entire next screen slides into view. That's one way of doing it. But then there's another way of doing it, like, which we've already seen, right? Several times by now, I think. Where, let me find the overworld. There we go. All right, see, I'm walking, and the screen is just smoothly panning as I walk. I think that's what I want to do. That makes more sense to me, to do it that way. However, I do want you to notice the difference here is that it looks like the character stays in screen position right in the center the whole time. Let's watch. Yeah, the overworld starts panning as soon as I move, and my guy stays in the very center of the screen the entire time. I'm not sure I want to do it like that either. What I think I want to do is sort of a hybrid situation where the world stays still until my character gets to the edge, and then once my character gets close to the edge but not quite to the edge but just close to the edge of the screen, at that point, assuming that I'm not at the edge of the world will then start panning. It's almost as if I'm pushing the camera as I walk towards the edge of the screen. That's my idea. Okay, so in order to... Alright, so first things first, I think I'm going to update our overworld map a little bit. Open this guy. Okay. So the reason why is because if I'm going to start venturing off of the first screen, I'll barely be able to tell whether I'm panning because all of these grass tiles are identical, so it's just like an endless field of grass. So how about I make some water features over here. Going to make some water features. And I'm just randomly... Here else is a river. And we'll do something over here. Like that. We'll put a big lake over here. There. I think that's good enough to get started. I'm really looking forward to designing this overworld. It's going to be really fun. All the lakes and rivers, and you have to name everything with, like, cool Tolkien-esque names. It's going to be a lot of fun. Anyway, I think that's good enough. I'm going to save this, or actually I'm going to save it. Then I'm going to export as image. Overwriting overworld1.png, export. Do you want to replace it? Yep. Okay. Now I go and find my repository, assets, maps. Okay, overworld1.png, open with paint.net. Just so that we can save as a 32 bits per pixel BMPX. Right there, replace, and that should be good. Let's go back into Visual Studio, launch it, see what it looks like. Well, we wouldn't know because everything that I just drew is off the screen. So I remember, I think I already put the camera. Yeah, we already have a global camera variable, so maybe I go check overworld. Yeah, PPI underscore overworld. Hold on. Where? There's my G camera. It's a U point. And I've already, in blit background to buffer, I've already accounted for the presence of a camera X and a camera Y. So all that should be left is to assign to it. So let me do that. In overworld.c, PPI underscore overworld, we'll say if down key is down, and okay, what are we going to do? What are we going to do? Yeah, do you guys know what I'm talking about now? Like, if this isn't causing me a problem now because I'm in the upper left corner of the overworld, but if I'm all the way at the bottom of the overworld, imagine if I were at the very bottom of the overworld and I get here and I press the down key and I walk downwards off the edge of the world, I would crash right here because +1, like, if I have a maximum y coordinate and then I say, I want to see the +1 of that, is unreadable memory. That's beyond the bounds of the array, right? So this is going to crash. Still not doing anything about it yet, though. I'll fix it later. All right, I'm thinking really hard here. Can move to desired tile if direction down, movement. Yeah. Okay. I guess, okay, if gplayer dot if screen position is I don't know if that's what I want to do or not. If okay, so we're going to say if our screen position, and this is while we're moving right, we've already decided that we can move right. We just need to decide, are we going to move the player on the screen, or are we going to move the camera to pan the camera? If screen position is less than that, okay, this is not where I want to insert this logic, because this is not where we're not modifying screen position or camera position either way here. So where I actually want to do this process player input, movement remaining. Okay, here we go. There we go. Here we go. This is a much better place to put this while we're moving. Okay. If gplayer dot screen pose dot y, if it is less than, oh wait a minute, I don't want to do down first, I want to do right first. If gplayer dot screen x is less than the res width minus 64, then I move the player on the screen. Else, if I'm closer than 64 pixels to the edge. Then I want to move the world and not the screen position. Let's see what that looks like. I'm just going to take off, walking to the right. It doesn't work. Okay, why is my camera XY? Oh. Yeah, that's not good. That is all kind of messed up. Hold up. I should not have been doing world position. I should have been doing camera. Is it not G camera? Is it not G camera? Where are you? Where are you, G camera? No, it really isn't. Yeah, there it is. Oh. This is why it's not working. Camera. Camera. Gotta put it in main.h. Is the problem. That is the problem. Put it down here with all these other global declarations. There it is. Back to here. Okay. Okay. So, if I'm moving to the right, if I'm less than 64 pixels from the right edge of the screen, then my player will move, the screen will stay still, the world will stay still. However, if I'm closer than 4 tiles to the edge of the screen, then the camera will shift. Let's see what happens. And then I guess we increment world position unconditionally, regardless of where I am on the screen. Come on. This is taking forever. Okay. Here we go. Are you kidding me? It works beautifully. It works beautifully. Okay. Now we can do all the other directions. Let's do left. We'll do it the exact same way. So if gPlayer.ScreenPosition.x, if it is greater than 64, yeah, if it's greater than 64, then we'll just move our character on the screen. If it is less than, we will move our camera instead, and we're going to move our world position regardless, gCamera.x minus. Okay, let's Let's run it and see what that looks like. So I'm pushing towards the edge of the screen, panning the camera. Now I've changed my mind. I'm going to go back the other direction. And then when I reach the edge of the world, I crash. Okay. All right, stop that. Stop it. Stop it. What went wrong? What did go wrong there? Did our camera go negative? Like, did it wrap around? Did it go below 0? Let's check that one more time. Our camera, oh yes, our camera is at 0, 0. So our camera is actually at the top left point right here. Right? So I'm going back the other way. Now, when I get back to 0, there, when the camera reaches 0, I can no longer make the camera go left anymore. The camera can't go left anymore. So it should be easy enough to fix, right? If screen at 0, X. Seeing how much time I have. 19. It's 34. Okay. Just a few minutes left, I think. Okay. Here we go. Making my way downtown. Now. I can't move anymore. Okay. When that happens, if camera X is greater than 0, should that happen though? Yeah, because my X is no longer greater than 64. So we fall into here. If camera X is greater than else, we're going to do G player dot screen pose dot X minus minus. This is great because see, notice now that my world XY, my world X coordinate is greater than my screen X coordinate, which is exactly what I was going for. Now let's see what happens when I get to the edge, the left edge of the world. My camera, screen, okay. Beautiful. Yep. 64. Perfect. I'm quite pleased with this. Let's finish the other directions. I kind of, actually, you know what? I kind of want to, all right, you know what I'll do? Since I know we have a few minutes, so, sorry, I'm giddy with excitement here at how well that worked. I'm going to go all the way to the other edge. We may have to make the world bigger. I don't know if this world is big enough to meet my ambitions. Is that really 10 screens? 240 tiles? I don't think that's going to be big enough. Oh well, we'll make another one later. I just want to make sure that everything is working on all four corners of the screen, right? So let's make a bunch of water here. Just with some random water tiles. Oh, and of course I'm going to be making different water tiles at some point so that not every tile is the same, you know. It kind of looks like Europe a little bit, doesn't it? Like Spain. Anyway. Okay, there's that. I'll make a random lake here for no reason. Oh yeah, that's an up arrow. Okay, now let me go down to the bottom right. And we're going to draw a smiley face in the water. And then bottom left, I'm going to draw an R for my name. There we go. All right. File, save, export as image, export, replace, exit that, paint.net, open, PNG, save as, BMPX, 32 bits per pixel, save, overwrite. An I/O error occurred while writing to the file. What? What? An error occurred while writing to the file. Who? Let's try that again. I want to save that. I want to save as BMPX, save, replace, an I/O error occurred writing to the file. I'm trying to think why that would be. The game's not open. Do you think I leaked a handle to it? No, I couldn't have. Alright, I opened up Process Explorer here. And I'm going to see, can I find a handle to overworld01.bmpx. Search. Zero. Nothing matching. Nothing. I didn't leave a handle open to it. Not from my app anyway. Paint.net. What in the world is going on here? Source, repos, game assets, maps. Okay, overworld1.bmpx. Can I delete it? Yeah, I deleted it. Now, save as. Overworld01.bmpx. Save. Worked fine. Did it get set as read-only, maybe? No, it's not read-only. Why was Paint.net giving me an I.O. error? I don't know. But now that we have the new tile map, let's go ahead and do this. Turn on my debug. Oh, I need to walk around this river, don't I? I can't get there from here. Okay, so we need to implement going down. Okay, if direction is going down, if gPlayer dot screen position dot y is less than game res height minus 64, then increment screen position. Else, we are going to increment camera y. G camera dot y plus plus. But only if I guess we'll just have to fix that bug when we get there. Oh my. I don't know what happened to my bracket there. Okay. Let's try this again. Down seems to be working quite well. I still haven't done up. Oh, you can't see my character, sorry. He was behind the portrait. Come on. Okay, I'm gonna have to create some bridges across these rivers now. That'd be the perfect thing. Okay, I think did I close myself in? I did. I'm an idiot. Sorry. And of course I can't go up either because I haven't implemented that yet. Up. If gPlayer dot screen position dot y is greater than 64, or yeah, greater than 64, then we increment screen position, else we increment world, oops, sorry, that's not right. We increment camera, or decrement camera, I should say. What the heck? Yeah, we know why. We know why it crashed. We just need to get back over here, and we need to do if gCamera.y is greater than 0. Okay. Apparently I have to learn this lesson twice. gPlayer dot screen pose dot y minus minus. Okay, that should do it. Yeah, sure does. Still have camera 0, 0. Moving to the right, piece of cake. Let's move down, piece of cake. Move back up. Easy. Easy peasy. Works pretty well. Alright, so what we're going to do next time is I do want to test how the camera works in all four corners, just to make sure that I've gotten all the bugs out of our movement code, and to make sure all the panning works correctly. There's no more crashing. Oh, that's how I get out. I could have gotten out of there if I'd have gone back up. And then I could have walked all the way across to the other side of the world. Then I could have walked down. It's okay though, doesn't matter. Next time, though, what I would like to do is I would like to create a new type of tile that's like a bridge, and I could place a bridge right here over the water, and then I add that to our array of passable tiles so that you can walk over the bridge. All right, that's awesome. I'm going to close that. So I'm going to call it for today. And as always, thank you very much for watching. If you enjoy this type of content, you want to see me continue development on this game, then please like and subscribe. And thanks again for helping me get past 500 subscribers. That's awesome. Can't wait for that 1,000 milestone. So yeah, like, subscribe, tell your friends, etc. Also, if you have any questions or comments on any of the content on any episode, please don't hesitate to comment on the videos. I will address any interesting comments in an upcoming episode. Lastly, also do not forget that we have a companion GitHub repository. You can go there and clone the repository so that you can build this yourself and you can follow along at home. So with that, I'm pretty pleased with the progress that we're making. I will see you next time. Bye.